Okay, we're back again. Now that we know how to find missing sides and missing angles of right triangles and oblique triangles, we want to tie up the topic by talking about a concept from geometry, area. So guys, what does it mean when I want to find the area of a triangle? Well, we all know the word area means the space inside, the amount of space. Well, we have to understand trig by always going back to geometry. So if I asked you from geometry, what is the formula to find the area of a triangle, you should all know that formula by heart. Area equals 1/2 the base times the height. Look familiar? Okay, in this triangle, who would be the base? That is correct. The base would be AC, the bottom. Who would be the height? Would the height be AB? No, because height's not diagonal. Would the height be BC? No, because height is not diagonal. Use your common sense. When you go to the doctor and they measure your height, do you stand like this, slanted? You stand up and down. So the height of this triangle would be if you draw it in. You all agree? This would be your height. Well, sometimes we don't know that height. If it's not in the picture, we don't know it, we'd have to find it. Well, that's a lot of work. So what we're going to do is we're going to rewrite this formula as a trig formula, okay, which means it's going to have a trig function. Think about this. We did this all the way back when we were talking about arc length and area of a sector. When we took the area formula for a sector of a circle, we looked at the geometry formula, and then we changed it into trig by using radians. The same thing here. We're going to start with this formula that we know from geometry, and all we're going to do is transform it into a trig formula. So how do we do that? Well, to transform this into a trig formula, it needs a trig, one of the trig definitions, sine, cosine, and tangent. So what happened is when they drew the height in, we know this is perpendicular, we make two right triangles. Okay, so mathematicians said, all right, let's again work with this acute angle. And they said if you look at this acute angle and we do the sine value, sine is opposite, which would be h, over the hypotenuse. And we know if that's angle C, we can call that side C. So we can look at this triangle and get this definition. The sine of angle A would be h over C. Do you all agree with that? If we cross multiply, we get h equals C sine A. What can we do with this piece of information and this geometry formula? Well, everybody look. They both have h in common. So can't we do a substitution? Can't we take C sine A and put it in this spot? So what we get is a new formula. We get A equals 1/2 base B C sine A. That is your new formula to find the area of a triangle. Now you're probably saying, why do we need that? Why can't we just keep this? Because if you look at this formula, do you need to know the height? No. To use this formula, you need to know angle A, you need to know side B, and side C. So you would never have to go and get that height. Okay? If you look, if we need to know angle A, side B, and side C, what pattern is that? That's side, angle, side. Side, angle, side. So you know you can use this formula to find the area of a triangle if you have the side, angle, side pattern. Okay? All right, so let's look at an example. So in your notes, there is a word problem. It says a real estate agent wants to find the area of a triangular lot of land. Okay, so let's draw a triangle. And it says the two sides. So we know one side of this triangle is 52 1/10 meter, and the other side, it doesn't matter which side, is 21 3/10 meters. And the angle in between these sides, that's the key word, the angle in between. So it's not that angle, It's not that angle, it's this angle. That's the angle in between the two sides, is 42 and 2/10 degrees. And the agent wants to know the area of this lot. So everybody look at me. Here's where you're going to get confused. We've been working with oblique triangles. We've been doing law of sines and law of cosines. Law of sines and law of cosines finds missing sides of oblique triangles, missing angles of oblique triangles. I am now asking for the area of this triangle. If I'm asking for the area, you do not use law of sines or law of cosines. You do not use SOHCAHTOA or Pythagorean theorem. To find the area, you now got to resort. Again, would we want to use this geometry formula to find the area? No, for two reasons. First of all, we don't know which of those sides is the base. And secondly, we don't know the height. So why should we use this old geometry formula when we have this new trig formula? This trig formula to find the area of a triangle says as long as you know the two sides and the angle in between, you have enough to fill in this formula. Do we have two sides and the angle in between? Yes, we do. So all we'll do is now substitute. So our formula is area equals 1/2 BC sine A. Area equals 1/2. One side, doesn't matter which one you put first. The other side. Do you know why it doesn't matter which one you put first? Because what operation is connected them? Multiplication. And the commutative property of math says it doesn't matter what order we multiply. So I don't care who you call side B or side C. But then angle A is in between. Okay, think about it. If I labeled this picture, that would be angle A, that would be side A. I'd label one side B, one side C. Now all we got to do is this calculation. All we have to do is type that all in our calculator. I do have a recommendation. Because this number's a decimal and this number's a decimal, I would suggest before you go to calculator, rewriting a half. What is rewriting a half as a decimal? It's 5/10. That would just be a lot easier to type in your calculator. Okay, what mode do we have to be in still? Degrees. So let's go to our calculators. So we would just type in we're in degree mode, always check your mode. I'm going to type 5/10 parentheses times my first side, close it, times my second side, close it, and then I'm going to hit the sign button and then put my angle and close it. And remember, because we're in degrees, we don't need a degree symbol. And this is my exact area. And then you have to read, and I would assume on this word problem we want to round to the nearest tenth because the other two sides were given to the nearest tenth. So 7 is in the 10th spot. There's a 1 behind it, so that would say a 7. It would not round up. So we would say the area of this lot is 372 and 7/10, and its area, these were measured in meters, area is always squared. See? See how nice that is? So think about it. If all you had was this geometry formula, you'd have a lot more work to do because you would have had to draw in the height and found the height first. So that's a quick way. Now, just like our law of cosines, this area formula doesn't have to be BC sine A. If I had side A and side B here, then this would be angle C. Okay? If I had side A and side C here, this would be angle B. So it's the two sides and the angle in between, which would be the other letter. Okay? Now, it just so happens there's another formula for area of a triangle. All right? Let me erase this. Okay. The next formula for area of a triangle that we can use that's new or different is called Heron's formula. Now, in your textbook is the development of this formula. It's too long for me to sit here and videotape where it came from, so I apologize. Okay? Let me write out the formula. Heron's formula is area of a triangle is the square root of S times S minus A times S minus B times S minus C. Well, we all know A, B, and C would stand for what in the triangle? Right. It would stand for the three sides. We would have to know side A, side B, and side C to work Heron's formula. Do you see any angle measurements written here? No, there's no big letters. So to use Heron's formula to find the area of a triangle, you would have to know the three sides. Side, side, side. Now in this formula, there is the letter S. So I got to give you the definition of what S is. In Heron's formula, S is half the perimeter. What does perimeter mean to do? Perimeter means to add up the three sides. So if you know the three sides, you can add them up, get half of that. That would be your S number. And then you'd put your three sides in. Now I know what you're thinking. You're saying, what does this formula have to do with trigonometry? There's no trig function. Again, if you go into your textbook and look at the proof of where this came from, it involves some trigonometric functions. Okay? So that's why it's placed in the trigonometry course. Okay? So again, just to sum up this chapter, we can find area of triangles without having to rely on the good old geometry 1/2 base times height. All right, so look at the example here. It's another word problem. This one's real life. Find the area of the Bermuda Triangle. We all know the Bermuda Triangle is in the Caribbean. Okay, if the sides have approximate lengths of 850 miles, 925 miles, and 1,300 miles. So we're talking about the Bermuda Triangle. We're talking about the sides. Does it matter which one you label A, B, or C? No, I labeled them in order. So side A is 850 miles. Side B is 925 miles. And side C is 1,300 miles. Again, if we had to rely on just geometry, we'd have a lot more work to do. Because from geometry, you have to know the base and the height, which means you would have to draw the height in, the perpendicular in. You'd have to use trigonometry to find that height first before you could find the area. Why do all that work when Heron's formula says if you know the three sides of the triangle, let's find the area? But before we can substitute in Heron's formula, what do we have to find first? We have to find half the perimeter. So we have to find S. So S is 1/2 of 850 plus 925 plus 1,300. Okay? We type that in, and you should get approximately, or exactly, 1,537 5/10. Okay? Do not round that. Use the exact value. You need to know exactly half the perimeter. So now we're going to do our substitution. A equals square root. First thing is half the perimeter. If you want, you can put that in parentheses. Then we're going to do S half the perimeter minus side A. Keep going. S minus side B. Parentheses, S minus side C. Now let's talk a minute before we even go into the calculator. First of all, we're dealing with a square root. What do you know about if you did a square root of a negative number from college algebra? Good. You should all remember from college algebra, there's a huge difference between me asking you the square root of 9 and the square root of negative 9. The square root of 9 is 3, because 3 times 3 is 9. The square root of negative 9 should not be a real number. It should be the opposite, which is imaginary, and it's going to be 3i. So the first thing I want you to notice is when you find half the perimeter, this number has to be bigger than your three sides. Because when you subtract, this has got to be a positive. This has got to be a positive. This has got to be a positive. So ladies and gentlemen, if you get a negative number down here, you screwed up. Okay? If we're finding area, area has to be a positive number. And to do a square root, everything under here has got to turn out to be positive. Y'all with me on that? So I'm just giving you that helpful hint. Half your perimeter has to be bigger than your 3 sides to keep everything positive. Now, again, you have wonderful calculators. You could type this in your calculator in one fell swoop. So let's go do it. All right, so I'm going to turn my calculator on. So, how do you get your square root button? Whether you're using the Pro or the 30, the square root button is above x squared. Here is my x squared, there's my square root. So I'm going to have to hit second. Here's my x squared, it's a square root's above it. I'm going to have to hit second. So I'm going to do second square root. All these new calculators automatically put in open parentheses. That parenthesis says whatever's coming now is all underneath the square root. So if I'm going to type what I have there, I'm going to open another parenthesis to type half the perimeter and close it. I'm going to type another parenthesis, do half the perimeter minus side A. I'm going to put another parenthesis, half the perimeter minus side B. Another parenthesis, half the perimeter minus side C. Now, I got to put one more parenthesis. I got to close in this whole expression. So I want you to understand, this parenthesis right here matches with this one. This is for the S minus C. But this parenthesis here goes all the way back to the beginning. Let me show you. If I go all the way back to the beginning, here it goes, a little bit more. That parenthesis at the very end matches with this parenthesis that says all of this now, all of these numbers are underneath this expression. And that's the important part. So I'm going to hit enter, and there is my answer. Okay? And because we had our sides given in miles, I would assume they want us to round this to the nearest mile. So the area of the Bermuda Triangle is approximately 392,129 miles squared. Okay? Everybody's good? So you're going to have to practice using your calculators. All right, we have one section left. That's more application problems that ties in law of sines and law of cosines and area. So I'll see you in the next video.